Okay, so the last question is this. Can you all see my screen? Okay, so the question is the minimum number of k consecutive bit flips. Here, for example, so what's the question is we will be given the k number of bit flip which we need to do at a time in a contiguous array, and what flips is like you can go from 0 to convert 0 to 1 and 1 to 0, but the thing is you need to make all the zeros to 1, and if any one of the 0 is in the end, if any one of 0 is not 1, then you need to return -1. The main goal is to make all the zeros to 1 and in a k bit flips, and how many steps you take to make these zeros to all 1, that number of steps you need to return, and the minimum number of steps you take to return it, that's an answer. For example, over here 0 1 0 0 1 0, we are provided with k is equal to 1, and over here if we flip, first of all we flip the first 0 to 1. This is a step 1, and then we see we move again in an iterative way, and if we see any other 0, then yeah, we make it 1, and and that step is 2. So this is one thing, and the main goal is how you make minimum number of steps to make all these elements into 1. And for example, over here here it's written you need to convert two flips, like at most 2 k bit flips you need to done in a subarray. Here it's not possible to do. Like if you convert this for example, if you convert like 1 1 0, and if you start at if you take these two, this would be 0 0, and the rest is also 0. For example, here 0 0 0. Then you start with another pair, then you'll convert this to 1, this to 1. So you can't make this 1 1 1 at a time, like 2 bit, you can't make it. So this will be like -1. And this is a good example to make how we are making it. So first of all, we need to make at least 3 bit flips at a time. So starting with we make 1 1 1 over here, and rest is same. So this is 1. Then we move ahead, and we used already which we created, and here we made this 0 to 1, and this 1 1 to 0. So we attempted 3 at a time to make it to convert it 0 to 1 or 1 to 0, and this is step 2. Then what we are left with we are left with another, all the 3 which are left is 0, so we make them 1 1, and this is converted, and this is the last step, because every item is 1 in the array, and this is a step 3, and we need to return this 3. Minimum number of steps we have taken. Is this question like anybody has any doubt about this question?
No.
Or is there any problem in understanding this question? Okay, so what would be the approach? We need to first of all think by what thing comes in our mind first of all, how we this can be solved? Frankly speaking, when it's written minimum, the thing comes in my mind is like we can go for a BFS, like minimum number and
Yeah.
breadth first search. But is this breadth first search would be applicable in this kind of a problem? Any thoughts? Mm. Anyone has tried this problem? Or I don't know. Because this seems to be a hard problem, and if anyone has any approach and want to share or any thoughts, that would be very grateful because I am also lacking in this kind of problems. Okay, I think no one has any has done this question, so let's try. So for example, if we have 0 1 0, what first thing we should do in, and we have k, we need to do case, we need to move k steps, like k, not k steps, k flips at a time, and the target is to make everything one. So these are the first thing we need to at least take k flips in array, and then we, other thing is we need to make it uh, all one. So this is the main goal, and to make it, and minimum steps.
I
So if
believe the brute force can be like we have the array, find the, take like the first example, or maybe any good example.
uh,
Okay, like in the first example, k is 1.
yeah,
I believe the brute force can be find first 0.
yes,
Okay, and then start flipping from there up
like
to the length k. So 1 1 0, repeat, find another 0 in that array. Okay, repeat the same problem. So in the second time when we repeat the repeat, we will find the third 0 and then we flip it. Okay, take maybe the third example.
yeah,
If
third
possible.
example would work,
Can
yeah.
you scroll down a little bit on the left?
Yeah, sure.
Like scroll down, like, so we can see the example.
Okay, okay.
Yeah, second, third one. Yeah, like if we take the third example.
Yeah.
Okay, we find the first 0 which is at the 0th position,
Mm-hmm.
flips is flips is like everything to 1. Yeah,
Yeah,
up
like
up middle and 3, 1 1
and
1,
three,
then
yeah,
1 0
one.
1 1 0. Okay, now find the second 0.
So
Yeah, iterate again, find the nearest, like the first 0, repeat
it's
the process.
it's in, yeah,
It will become 1 and then 0 0
sorry,
1.
it will be 0 because we need to do k flips at a time. So
Okay, yeah,
the,
okay, yeah. So we are not taking that, and then again find a 0, the first occurrence of the 0, and then flip it.
uh,
Okay, and then verify if everything is 1 or not. Okay, so so I believe like this is simple brute force approach, and we
while,
have to, yeah.
yeah, to do that we like to make it, I think XOR would work to check if, to make it a flip, like XOR with
Yeah.
one would
Yep.
work.
And like just to take on the same approach that I talked about, what
Yeah,
comes to my mind is maybe we can do a first pass on the array like one time to store all the location occurrence of 0. Okay, maybe in a queue or something, or
Okay.
or in a min queue. So
Mm-hmm.
so we always know like where the first 0 is.
Mm-hmm.
Okay, and then when we are flipping, we know okay like where the first 0 is. From that index, uh, do the up to the k length, do the flips, and if there is any one which turned into 0,
Mm-hmm.
put that index back into the priority queue. So we know okay where to find the next 0.
Yeah.
Okay, and
Put index of that, or yeah, we
and
need to put index. Yeah, we need to put the index
yeah,
of the which is
zeros, and also like maybe during the first iteration we
mm-hmm.
can keep a count of number of zeros which are currently there. Okay, so as we perform each operation, when we are flipping 1 to 0 or 0 to 1, we can check, we can increment or decrement the count of zeros that we have, and anytime count of zeros becomes 0, that's our breaking point.
Okay.
Okay,
Yeah.
that's a simple brute force that comes to my mind. I'm not aware of any better optimized approach.
Coming to this particular, which you said, if I want to optimize it, let's pass from like normal iteration we do, uh, from like how we do the normal iteration. If I start with this index, I saw that this is
So
zero. I
yeah,
take another pointer and iterate till that, till k, where like till k, I'll change I'll flip everything.
yeah. So in the first pass we traverse the whole array,
Yes.
let's say, and then put like take a priority queue. Okay,
Ye-
maybe just write something and then we will put the index. So indexes are 0, 1, 2, that will go in that queue.
Zero,
0, 1, 2, then
3, 4,
4,
7.
7.
Yep.
Okay, and then have also have a variable count.
Mm-hmm.
Okay, and so this will denotes how many zeros are there. Okay,
So
so those will be like 4. Count
4,
will be 4 to
5,
start with. Okay,
5, right? 1, 2, 3,
yeah,
5.
5, sorry, yeah, it should be 5 to start with.
Yeah,
Then from the priority queue, what's the index of the first 0?
it's 0.
Okay, and we know the length is 3. So
Yeah.
so take 0 out from the priority queue. Okay, and then start flipping. We find first, we convert it to 1.
Because
Okay,
we need to make till k index. So whatever the index we got, like 0 index, we need to go till
okay.
k, like 0 plus k,
And
or
then
like, yeah,
make them like 1, 1, 1. Okay, like the first 3.
yeah, first
Okay,
3, yeah, 1,
will become 1, 1, 1, and then yeah, like remaining 1, 0, 1, 0, 1, 1, 0. Okay, and by this time the priority queue, whatever the priority queue we have is 1, 1,
1,
4,
2.
7, and then the count will reduce to 2, because when we are flipping, we will decrement the count if we convert index to like item at that index to 1, or
Actually,
otherwise
we
we
don't even need the. Actually, we don't even need the count. If the priority queue become empty, that is actually
no, it's not guaranteed. Like priority queue may not become empty. Yeah,
But
like yeah,
the priority queue, from the priority queue we dequeue the first index, but right now our count is reduced to
yes,
2.
yes,
So
yes, yeah. So we also need to remove
update,
those indexes from the priority queue. Then priority queue might not be a right data structure.
yeah. So um, so what I was thinking, like following this approach of yours, if we take a 2 pointers, first of all we start with the 1 pointer and point like normal iteration will till the length of this array, and when we see 0 at that index, we take another pointer, some j or something, and we'll point the pointer which was iterating, for example I. and we'll iterate till k of that, like j, whatever the k was there. We'll iterate and flip all those elements which we have, like which we need to which we need to make it flip. Actually, we need to make flip till k. So whenever we saw a zero, we'll flip it at time, and this time it will be like at this path, it would be like this. This would be the step one, and after that, after the we again our pointer will reach to this particular position, but now our array has changed to this, and will not do this. This will continue because this is one. So we'll move ahead till we get a zero. So here we get a zero, and we need to the three flips. And here, if we go for and our pointer will change again, and we need to make a flip, and we will flip. Sorry, it's somewhere down. I just copied, and we make a flip of these three, and we'll make it 1 0 0. So this would be our step two, and then now our pointer will reach. Our pointer is moving. For example, it was over here. So I think we have a doubt. So now, we changed last bit over here. So now our pointer will reach over here because it is again a zero. So we make those flips again at 3, and when we are flipping, we need to check that whatever the pointer we have taken, like j, it should not reach the end of the length. It should not increase the end of the length of the array. And so after this, we have an answer of making. After this, we will be having 3 steps. It's also an iteration, like iterative way to make it a flips. And but the complexity, I think it would be more. Yeah, complexity would be more, because we are traversing that point again to check it.
So I think Gaurav idea is also fine. The queue, you put all index of zeros, then start removing one by one. And if let's assume at some point we remove an index which is already one, just ignore that and then go to the next index.
The only thing is, if we are in the priority queue, we put like this 0, 1, and 2. So if we dequeue
First we remove zero.
Yeah. So and we made these flips 3.
Yeah. 1 1 1.
Yeah, 1 1 1 because we're having 0 0 over here. So we need to dequeue these 1 2 as well.
Yeah. So next time 1 will come. It is already 1, so we ignore it. And 2 will come. It's already 1. Ignore it. Then 4 will come. It's 0. Then start with that.
Okay. 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 So if it is 4, then
make 4, make it 1.
And where
and
we
put 5.
The steps, whenever we dequeue something from queue.
And this is 0. And this is 0.
Sorry?
When we dequeue and check also it says 0 or 1.
Okay. Okay, so whenever we are making a dequeue, we increase the count of steps. Like we are able to succeed to make a dequeue. Then we are increasing the count. Okay. And then we make all other as 0 0.
0. Put these 2 in the queue, 5 and 6.
So yeah, the problem is we worked for 4, and now our next pointer is pointing towards 0 at 7. But now our flips are...
No, you put 5. You also put 5 and 6 in the queue.
Oh, we need to put the 5 and 6, which will be like 5, 6 and 7. Okay.
So then you remove 5,
And we pop
then
it
put 1,
1.
1, then again next one 1, 1, and then you start removing things from the queue, 5, 6, 7. Everything became empty.
Yep. And side by side, we are checking if they are already 1, 1. So we are not doing anything. And our count is the last, which we did, 3. Okay.
But my question is, in the same example, if you can take it again, there is one more 0 at the end.
Where?
Yeah, in the same example, one more 0 at the end.
This 7 number.
Yeah. It is copy again and you can press 1.
So okay, so this is so you want me to put one more 0?
Yeah, yeah.
Okay. So now our
Similar approach. First we'll make 3.
0, 1, 2, 4.
No, first yeah.
This will be a queue.
Or you don't need to take a queue, just choose without that only, assuming you know the 0 thing.
Okay.
So what will happen first time?
The first time we'll start with the index which having a 0.
So we'll make 1, 1, 1.
We need to iterate till our queue is empty. Like
It's
that.
okay. Assume you know like where all the ones, where all the zeros.
So
Can you
here,
please start?
sorry.
Can you just make first 3 zeros as 1?
So our arrays, you are changing the array, or this would be the array only.
This would be the array.
And we are making these flips. And here we remove 0. And when we are dequeuing 1, we will see that it is already 1. So we are not moving further. And then also 2 is already 1. We are not moving further. So we checked 4. We saw it's a 0. We'll increase our count. And so 4 will removed and we'll make these flips. Sorry, I'm doing over here only. 0 and 0. So, and while we are making it a 0, 0, we'll also put those indexes over here. So the only operation we need to put 0, 0 in a queue, like indexes in a queue whenever we are flipping 1 to 0, not from 0 to 1. So because here we did 0 to 1, we will not put that index in a queue. We only put in a queue when we are converting 1 to 0. Because this queue is for only the zeros. So that's why we are making updation like that, as you are saying. Correct? So
now what's next?
Next is we dequeue 5 and we make 3 attempts, next 3 flips over here. And when we see again we see 6, we'll remove 6 from here, then we'll remove 7, and now we have 8, and 8 is over here, and
So now I can do 3 flips.
We'll not be able to do 3 flips. Correct.
So that time what should I do? Go back and flip it?
I don't think so. Anyone approach? Anyone has is following this thing?
Sorry, I can't see too much in my mobile, but I think if you can't reach the solution, you have to return -1 also, right? somewhere in there.
Yeah, we need to return -1. So yeah, so maybe the answer is -1 over here because we have changed our array. So that would make sense, and we need to, if we are not making
Or
it,
can
answer is
or you
-1.
can run this example in the console and see what result we get back.
Sure.
So by the way, this solution was based on one assumption that like changing or flipping the leftmost zero is will give you the best solution, right?
Changing.
Yes.
So you can call it as a greedy approach. Like you made a local decision and you are hoping that this will give you the best solution. Which
Correct.
yeah, and why it works, because suppose you don't flip it, then suppose like the first leftmost candidate was itself 0 and you didn't flip it, maybe now, and you started flipping the second, third, fourth one, and your window size is not just 1, suppose it is 3. So the thing is, in future, to get all 1, you have to anyway flip that guy, right? And you can't flip that guy alone. You will have to flip the neighbors also. So if you think about it, then you will see, hey, that will cost me more not to flip now and do it in future. So that's why this greedy approach will work. Like that is how you will confirm that this greedy way will lead me to the best solution.
But initially, I thought looking at the solution, you remember, Roger, we did a lot of questions here, do breakfast search, like the one we did for parentheses, change one state to another. But it seems like that is not the solution here.
Right.
I don't know how.
BFS, so see, BFS, like, you know, you will have the same kind of a state. It will work, but not the best time complexity you will get. Like, yeah, like you can choose all the candidates, possible candidates, and like you will get n minus k elements in the first step, right? Like if you say, like, you know, level 1, level 0 is when we start everything with the given thing. Level 1 will have n minus k candidates, and then you have to make sure, like, you know, they are unique also, so don't process them. But every time you will from n minus k, you will reach another, each of those will again reach n minus k, right? So it is growing exponentially, like n square, then n cube, something like that. So you will be able to find, but the time complexity would be terrible. Also, here you are flipping, so 0 becomes 1 and 1 becomes 0. So a lot of things will repeat. Like it's not like it's from A, B, C to Z or something like that. Just 2 values for each possible, like, you know, index. So while you are doing this thing in any approach, if you flip anything 2 times, you are basically reaching to the same place, right? At least its value will be same. So you can use that, like, you know, if you are doing it odd number of times or even number of time, you can use that to optimize even the current solution, basically, like how to do that. So, I mean, if you think like that, this is a good approach. This will work. With optimization, I think it will work.
Thank you so much, Roger.
Yeah, no problem.
Okay, so I think we are out of time. And if anyone has any questions, I'll stop the recording first.